How's everybody doing today? I'm good. Thank you. So I told you all last time that whenever we do tutoring, we're going to have to sign in at the very beginning. So if y'all can just type this in, I prefer y'all did. If not, that's obviously up to you too. But if y'all could just type this into your computer or phone or what have you and fill that out real quick. I'll try to have this up better, faster next time. But it's just a helpful guide for y'all. For those of you who do struggle with some classes, all Parker's trying to do is see kind of how much effort you kind of put into it. And so if you've been going to tutoring sessions and you've kind of just shown that proactiveness, it'll look better for you. It's supposed to help y'all. Can I blow it up? Is that? I don't know. I can just http://bit.ly/tutoring sign in. It's case sensitive. Perfect. Did you capitalize the T and the S and the I? It's case sensitive, yeah. So capitalize the T, the S, and the I. I'll have this up faster so we can just get that done next time. On the positive side, I didn't want to get dum-dums because I didn't know if that would sound bad, so I got Smarties. It's the most healthy snack I could find, I promise you. It's not. That was a lie. But the 20th, I believe? Awesome. Does anybody still need this up? Okay. And if y'all could just save that even as a bookmark or something at the top of your computer, or keep your search history so that it can just be quicker, faster for when this happens next. 2
hours?
Yes. Yeah, just always put 2 hours for us. If it goes earlier or later, it won't go later. If it goes later, y'all can jump me or something. Oestreich. It's like the worst when you're trying to spell it. It's here or here. Y'all know my middle name is Wesley now. There. A lot of places. Cool. Give that another minute. And just put chapter 2. We'll just say chapter 2 for this week or chapter 3 next week, what have you. Just make it really simple. This is new, so we'll tweak it as it goes. All right, that's enough time. If you've done it, great. If not, I appreciate you trying. I'm too impatient. All right, next activity. Get a sheet of paper or just your computer or what have you, but answer those questions, please. Just working on that recall from last week. So just on your own, real quick. We'll go over them here at the end. Oh, I gave you the answer for that second one. That's awkward. There we go. None of y'all saw it. I'll give y'all a little bit of the answer. There you go. You can obviously tell I've planned this very thoroughly. Something quick, couple minutes. And when you're done, just put your pens down. I kind of have a rough idea. This is for a grade. It's not. Just get used to my bad jokes. You'll learn to appreciate them. I have. All right, most everyone done finishing up? Who's still working on? No hand. Oh, we got one. Proud of you for raising your hand. Good job. You can be loud closing the door. It's not really a big deal. You can. We're taking a graded test. You're late, so you fail. What's your name?
Hugh.
Q?
Yeah.
Andrew, good to meet you.
Nice to meet you, Andrew.
Oh, Hugh. Oh, I knew that. I met you one time already. I got my glasses on, but it's far still. We're going to write down Hugh was late. Cool. All right. Someone raise your hand and tell me what that functional group is. What? I heard it? Amido. Amido. With good hands, right? Okay. Versus an amino group, amido does have the oxygen, right? Right? We'll pull it up. Amido. What page are we on? Amido. Let's zoom in. Zoom in. Zoom in. Where's that? Why isn't this zooming? Zoom. There we go. Pushing the wrong one. Amido. Well, I guess, yeah, there could be an H on there, what have you. NH. So amido does NHC with the double bond O versus amino, which does not have the oxygen on it. So amino is just NH3. Amido is NH2, whatever, or NHC double bond O.
So does it matter that there wasn't two hydrogens in the amido?
Not really, to be honest with you. I mean, I guess I kind of took this for granted. I guess I could do that. Does that make it better? Or NH2? Does that make it better for y'all? Cool. Sorry. Way zoomed in now. You can't even see it. Zooming in more. It's backwards on this one. All right. What is a Henderson-Hasselbalch equation? Somebody raise your hand. No one? We got one hand. Hell yeah.
pH equals negative pKa plus log the concentration of the acid over, or not the acid,
What's the opposite?
conjugate base, yeah, and then over the concentration of HA.
Cool. If you just read it through my handwriting, proud of you. But if for those of you who need to see it, it's here once again. pH is equal to pKa plus the log of A minus over HA. So remember that the negative is on top and the hydrogen is on the bottom. Going deep. Going deep. Oh, don't be about there. Oh, that was so bad. Too high. I got that Aaron Rodgers. I can just trajectory it up, straight up. Underhand softball. Perfect. I'm an athlete, I promise you. I'm not. pH of blood. You can tell me pH of blood. I saw a hand in the back, but you put it down. I saw it, though. Say again louder. 7.35 to 7.45. Second question after that, is that acidic or basic? Is that acidic or basic? But it's basic. Yeah, good. If it's above 7, it's basic, right? If it's less than 7, that means it's got to be acidic. God, we're so smart, right? All right, who can give me an example of an ionic bond? We got a hand. Yeah, potassium bromide, that's cool. What's an easier one that we could? Salt, right? Good. And what? Someone else? Ooh, didn't see it. No one saw it. You're in the back. What makes an ionic bond? How does that bond form? Good. Yeah. So electrons are taken from one atom, and yeah, good. Fist bump. Are taken from one atom just like that. They hit each other. It steals it, making a positive and a negative charge, right? And those positive and negative charge are what make the bond. Are those strong or weak? Weak, right? They dissolve in water, and our body is what? Mostly water, yeah? So very weak. So are covalent bonds strong or weak? Strong. I guess I'll just leave now and just take the test. Are there any questions from last time? Do you have any other questions?
What's the difference between an ionic bond and a covalent bond? Like, I understand it's sharing and one is not sharing. One's sharing, the other one's transferring electrons.
Yeah, so one electron, an ionic bond, one electron is transferred over to the other, creating, so sodium chloride. Sodium chloride. Sodium's got one electron in its outer shell, in its valence shell. Chloride's got 7, yeah? We're trying to the molecule's trying to be as stable as possible. It wants its last valence shell to be full. Would it be easier to add 7 more to sodium or to lose 1? It lose 1, right? So it can drop down to this full shell here. So it gets rid of that one. If you lose an electron, you get a positive charge, right? You're removing a negative. So now sodium's got a positive charge. Chloride's got a negative charge now that it's got that extra electron. The bond comes pretty much just from the positive and the negative attracting each other. Whereas a covalent bond, they would pretty much add, I guess, kind of like add this electron, that 1 plus 7, or yeah, 1 plus 7 combined would make 8. And so they share each other's electrons.
I don't get that part. Sorry, okay.
No, it's fine. It's a good question. On the serum, let's use hydrogen, for example. This one's super easy. So hydrogen's first one, right? It's our first molecule, top left of the periodic table, or atom. They each have 1, yeah? Our first valence shell has a maximum of how many electrons? 2, right? Because there's only hydrogen and helium in that first one. So 2 max valence shell. Instead of each one of them floating around with 1 valence shell, or 1 valence electron, they could either lose it and just be H positive and have no valence electrons, which is totally fine. But what happens typically I guess, on Earth is that the hydrogens, they are H2, so there's 2 hydrogens. So they combine together and they share those 2 electrons, or they kind of put them together for the betterment of their stability and say, hey, together we only have 1, which kind of sucks. 1 is the loneliest number, right? And so they combine them to be 2. They both share those electrons equally together, and that sharing kind of creates the bond between them.
Okay. Thank you.
Does that help?
It does.
Cool. Any other questions? That's a good question. I got one guy just making his hair look good. All right, chapter 2, if no one's got any other questions. Chapter 2. Did y'all cover chapter 2 already in class? Yeah, you didn't have class today? Wonderful. All right. Amino acids, structure and properties. We have 3 different types of molecules in our body. We've got fats, carbs, proteins, right? All our amino acids make up our proteins. So this whole chapter is kind of talking about different functional groups on proteins. Test question is, oh, I brought a pen. Does anyone have a pencil? I hate writing in pen on these things. An extra one that if you don't mind parting with? Wonderful. Thank you. It's orange. It's a good color. Go Horns. Proteins are composed of amino acids. In humans, the L isomers, we use L isomers. The other one is D isomers. We'll get to that later. What does that mean? It's just L just stands for left, pretty much. Actually stands for levo-rotatory. Don't worry about it. It's L isomers are the ones we use. D is dextro, right? Anyway, TQ, all amino acids are L isomers. And we have 20 different amino acids. Have you all heard of like amino acid supplementation or anything like that? No? Don't worry about it. But pretty much all these do is they help construct proteins. And we're going to learn today what the basic protein or basic amino acid structure looks like. We're going to do a lot of drawing. So if you have scratch paper, wonderful. If you don't, just use your table and just like smudge it around. That's what I do a lot. I promise you, I'm a very visual learner. There's two ways of doing it. So if I can see the structure, that helped me a lot, especially with organic chemistry. So if those of you took organic chemistry, wonderful. If not, it's still fine. We're going to like drill it into you today. But there's also another video because we got to learn all 20 of these amino acids today, and we're going to do it. I promise you, we're going to do it. And but there's for those of you who like mnemonics or like using your fingers and like hands to remember stuff, I have like a quick video or like 8-minute video that we can watch, and that's really helpful for other people who aren't necessarily visual or kinesthetic, but they can use like their hands however they do. Anyway, all amino acids have the same basic structure. I'm tall, so I'm going to reach up. They have this alpha carbon in the middle, all right? Just alpha, just because it's number one. It's the alpha dog. It's important, what have you. Alpha carbon in the middle. It's got this H. What does H stand for? Hydrogen. So it's got a hydrogen bonded here. It's got a carboxyl group, right? Do we recognize that from the last chapter? Carboxyl. So whenever you see COO, negative, carboxyl. If it's a COOH, that's a carboxylic acid, right, with the H on it, carboxylic acid. Could also call it a carboxylate. Here we have our amino group because it does not have that oxygen on it, right? Just NH3. Just NH3. And this R group. And our R group is just something else. Pretty much just something else. It's like in math when we did algebra, when we just had X. Like we always had to solve X. Why didn't we use any other letters? Whatever. That's pretty much all it is. It's just like an X variable. And our amino acids are going to have, they're always going to have that hydrogen. They're always going to have the carboxyl, and they're always going to have the amino acid group. The only thing that's different is this R group. So what we're going to be doing for the rest of what's going to seem like forever is just learning all these different R groups. It's going to be a lot of fun. Maybe. It's going to be fun. All right, chirality. Need to know this definition. Definitely need to know this definition. That's just when this alpha carbon, when this carbon here in the middle has 4 different things bonded attached to it. Okay? For the record, these are covalent bonds that are around, right? So these are just, this carbon is sharing electrons with those things, covalent bonds. So this carbon, it's bound to a hydrogen, carboxyl, amino, and we'll just say an R group. Are those all different things? Yes, those are all different things. So that is when, so we would say that this carbon is chiral. It has chirality. if we were to make this R group in H, is that chiral? No. Why? Because it's something's the same, right? Something's the same. So that means it's achiral. It's not chiral. It's that simple. So just remember that chirality means they're all different. And then when it's achiral, that means something's the same. If you can just get those straightened out, that's all it is. Next, like we said, there's 20 different amino acids, and in humans we use the L ones. Don't really need to know why. I don't really know why, to be honest with you. And pretty much it just shows you here's a D1. What it means by to be L and D is just the way it rotates light. So chemists or whatever, they just looked under a microscope or they shot a beam of light at it, and the light rotated one way for L and the other way for D. But all it is just flipped. Different classifications of amino acids. So we have kind of our big umbrella topic is amino acids, and underneath the umbrella we have different categories. The first one's polar, nonpolar, aromatic, positive, and negative. If something is nonpolar, does it share electrons equally or not equally? Equally, right? So if something's polar, that means they share them non-equally, right? There's one kind of positive pole on this side and one negative pole on the other side. What was an example of the molecule that we used for polar covalent bond? Water. You all said it. I had one in my hand, but okay. Up for grabs. Whoever catches it. Did I hit the ceiling again? Oh my God. So strong. Cool. Amino acids ionize in aqueous solution. Both the carboxyl and the amino groups can ionize. Pretty much they can act as weak acids, weak bases. Not that important at the moment. Starting off, nonpolar, aliphatic, R groups. Everyone, scratch piece of paper. We're going to use it. Where'd that pencil go? Found it. If you only have a limited amount of paper, try to use a pencil so you can just erase. But draw the basic structure of an amino acid, if you can. So that's just going to be your alpha carbon, right? If you want to put a little alpha next to it, you can. Just one at the moment.
A big one, or we're going with a massive one?
Probably keep it smaller, just because. So it's got a hydrogen on it. It's got our carboxyl group. Is that amino or amido? Amino, right? They're amino acids. Oh, yeah, maybe that makes sense. Yeah. All right. And our R group. That's our basic structure of an amino acid. Do you all remember, is this chiral, achiral? Chiral. They're all different chiral. Make that R and H again. Chiral, achiral. Achiral. We've just learned glycine. So glycine, that R group, is just an H. It's just a hydrogen. It's the simplest amino acid that we have in our body, right? Doesn't get more simple than the first atom, the first whatever thing on the periodic table. Glycine. Glycine is the only achiral molecule, or achiral amino acid. That says it here. That's a TQ. So if he'd ask you, which of the following is achiral? And y'all are all going to scream. We're not going to scream it, but like you're going to circle really vigorously glycine, right? Cool. All right, erase that H. Actually, you can probably keep it. Make it a CH3. What is the name of that functional group? Just this. I'm hearing it. Methyl, right? Methyl. So CH3 is methyl. That's like the second easiest functional group that we have. And we've just drawn alanine. So we've already got 2 down, we're 10% done. Not that bad. So how we go from glycine to alanine is we methylate it. We pretty much just make it a verb, which is kind of awesome. You can pretty much just take any of those and say, like we can, maybe not, maybe methyl is the only one, but you can add a amino group or a amido group or whatever. 2 down. The next one we're going to do is valine. All right, so erase this one or just draw another one if you can. We're going to draw it a little bit different this time. So alpha carbon, hydrogen. What's this group called? Carboxyl. Can y'all see it? Sorry, it's kind of bright. I'll try to write darker. Don't want to use up all her lead though. What's this group called? Amino. And this one we're going to do C, C, C. Just like that. And can you all see that that kind of makes a V? That's valine. Valine makes a V. So why I point that out, because that is one of our branched chain amino acids. Pretty much is just people trying to say, hey, this is what it looks like. It has a little fork in it like a tree. There's 3 of them. We have valine, all right, sorry about that. All right, so there are 3 branched chain amino acids. First one's valine, it's the easiest, right? You see something V, that looks like a branch already, right? It's split, done. The next one we have is leucine. So what we're going to do here, draw that basic amino acid structure or erase it however you want. So carbon, hydrogen, carboxyl, amino, bless you. And we're just going to add another carbon to kind of make it like a Y. So it's going to look pretty much like that. That is leucine. So I'm going to have this drilled into your head: valine, leucine, isoleucine. Valine, leucine, isoleucine are your branched chain amino acids. Isoleucine, how that one works is it just branches at a different spot. So carbon, alpha carbon, carboxyl, hydrogen, amino. And I'll do it this way. This kind of looks like a check mark. Iso just means what, like same or similar? Yes, no, potentially. So it's pretty much just leucine, but the carbon, just this last carbon's in a different spot. So if you can think V, Y, and check mark, valine, leucine, isoleucine, you got it. And that's all it is. And we're already 20% done. All right, So the way that he's going to ask you is you're going to have to know what's special about what. So what's special about glycine? The only achiral one, right? Good. What are our 3 branched chain amino acids? Valine, leucine, isoleucine. Is glycine a branched chain amino acid? No. So this is how I'm trying to set it up for y'all on your test to be able to, when I take the test, I like for the right answer to just pop out at me. So if I can just drill this into you as opposed to like searching through it, like grouping them together like this, it just makes it a whole lot easier. Because he could ask a test question of which of the following is not a branched chain amino acid, and then you'll have valine, leucine, isoleucine, and you'll have like glycine as the wrong answer. So if you can just rattle those off real quick and be like, oh yeah, it's obviously this one, good to go. Cool. That might have been loud. So we've got 5 done, actually. That's 25% done. That's what I'm talking about. The drawing. That one? Yeah. Those are just carbons. I'm not going to like talk about all the carbon stuff too much because it's not worth your time or mine. Just the general shape. Question?
You have to write alpha.
You don't have to, no. It's just a way to just let me know kind of where I'm at and help y'all know where you're at. Good question. Did you get it? Do you need me to keep it up? Good. All right. Next we've got methionine. So basic amino acid structure. There you go. Y'all are going to know, y'all knew nothing, and now you're going to be like, oh my gosh, this is so tedious and monotonous. I'm so sick of this, Andrew. And it doesn't matter where you draw it, really. You can draw the NH3 up top or on bottom. I guess for consistency's sake, I'll just try to keep doing it roughly the same. It doesn't matter. So methionine is methionine. And the O is different, so that's important. Methionine is one of 2 amino acids that has a sulfur in it, right? Sulfur smells bad. It's that thing. And so methionine is one of 2 that has sulfur in it. And I just remember it, there's 4 syllables, methionine, CCSC. Which is kind of how I do that one. So methionine.
Does it matter which you drew it this way or this
Nope,
way?
not at all. Not at all. Whichever way works best for you.
What did you say about sulfur again?
That methionine has it. It's just, if you don't know what sulfur is, it's just like a natural gas that smells bad. The other amino acid that has sulfur in it, we'll get to it, is cysteine. But we'll learn more about that one here in a little bit. So that's methionine. What's important about it? Sulfur. Methionine, sulfur. Simple as that. Lastly, proline. Does it say anything about proline down here? Not yet. Anyway, proline, basic amino acid structure. And put the N on the left. So if you can, this one is actually the only one that needs a little bit of specificity on it. And H, we'll just keep doing. Don't worry about counting the number of hydrogens. I promise you it's not worth your time for this one. So proline goes like this. C, 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 and it makes a little ring. It connects all the way back like that. It's like a dog chasing its tail and it actually got it, right? How rare is that? It's really rare, right? The dog's always chasing it and we're laughing at it, haha.
Can you draw NH3 instead of NH3?
Can I draw out NH3? Yeah. Is that better?
Yeah.
Good. This is the only amino acid that does not have a free R group. So this is proline. Does not have free R group. And remember that R group is the thing that's just different on every amino acid. So the R group would be an H for glycine, it'd be the CH3 for alanine, the V for valine, the Y for leucine, the check mark for isoleucine. All those different things are just the R group. Everything else is the same. Proline is the only one that doesn't have a free R group. Got to know that. The free R group means that the tail of it, so here like on methionine, you see how this is kind of just like floating out free like that? Since this actually comes back and connects to it, you can say it's bounded. It's the only one that has a bounded, no. Only bounded R, not P, R group. Test question. And those are all, we've already learned 7. We're a third of the way there. Not that bad, yeah? Yeah, question. Yeah, like I said, don't worry about the hydrogens. It's not worth it. It should be NH2, you're right. It should, but I'm just choosing not to worry about it. Is that okay? We can talk about that in break if you want to, and I can draw it out perfectly for you. The last couple times I've tried to like change it and like write NH2 instead of NH3 or what have you. People are like, what the hell, you're changing the numbers? And I'm like, now I gotta like go into like actual structures of stuff when it's not worth it.
We don't have to care.
You don't have to care now.
Okay.
You don't have to count the hydrogens really. Yeah, that's what I'm trying to get to. You're like, big picture. Big picture. You're not gonna have to draw these on the test, but he might give you a picture and you have to recognize it, or most likely he's just gonna ask you what's important about it. So me drawing it is just a way of giving you kind of something to fall back on when you're like, oh, what's important about methionine? Oh, there's an S in it. It has a sulfur. Boom.
So on the test, he won't give you an option that has NH2 with the same like ring for
No, not at all. Not at all. That would be the worst. Cool. Question?
Okay, so these are all categories under the nonpolar aliphatic.
Yes.
What is that? What's that?
Aliphatic. I looked it up one time. I think it's just, does anybody know what aliphatic is? Just out of curiosity? Any smart chemistry people? I heard someone saying something. Straight chains. So it's just a straight chain. I looked it up one time, completely forgot. So, Clutch, what's your name in the back? Yeah? David. Good name. It's my dad's name. Yeah, so it's just a straight chain. So if you see, and he'll ask questions. He won't typically ask one of the nonpolar aliphatic ones, but he'll ask you which of the following is a polar uncharged R group or a positively charged. He'll ask you, and you have to be able to identify like that too. So if you can, just group them kind of how he's grouped them. Excuse me, and like make a flashcard if you like flashcards, or just write it out if you like doing that. Like, where are all the nonpolar alphatics, or what are all the negative charged ones, and just list them out. Because it makes it a really easy test question. Like, which of the following isn't one of these? And then if you were like me when you first took this test, I guessed and
Does he have
didn't
to
always
put
succeed.
pictures on this test?
No,
So it's
mostly
just like-
words.
oh,
It's mostly words. Cool. Next one are aromatics. Our aromatics. Aromatics, aromas, our smell goods, like our fragrances, perfumes, what have you. Tangents. The first one we have is phenylalanine. So we can probably just keep our same basic amino acid structure. We kind of know it by now. Yeah? Kind of getting annoyed having to draw it. Perfect. I've conditioned you.
The first 7 that we just did all nonpolar?
Yes, the first 7 we just did are all nonpolar. And to answer your question of why, to go just a little bit deeper, because they're all just carbons and hydrogens, right? The things that are going to be polar are typically going to be our oxygens and nitrogens. That's just because they have large electronegativities. Don't worry about it. These are our aromatics I'm drawing. Phenylalanine is just CH2, and it's got a ring. That's just a hexagon. There's 6. It's really pretty. I'm an artist. I'm not. I was in band. If you're ever in marching band, come talk to me. Swap stories. It's for all the cool kids. Phenylalanine. Do you remember what our phenyl group looked like when we did it last week? It's pretty much just that 6-ring carbon, right? So this is our phenyl group, yeah? Pretty much just a circle. And what is this amino acid? Alanine, right? So all they did was they took alanine and they put a phenyl group on it. Well, they didn't. Like, whoever created the universe did. But there's an alanine, they just put a phenyl group on it. So phenylalanine. Pretty simple, right? That's how it's named. It's an aromatic because of that phenyl group here at the end. It's just a circular structure, a ring structure, what have you. That's it. So you know that the phenyl group is just pretty much a circle. So it would make sense that phenylalanine is one of the aromatics. It makes a circle. That's the easiest one. Next, I'll write it here, phenylalanine. Next, we have tyrosine, and how we go from phenylalanine to tyrosine is we just put an OH on it. OH is what type of functional group? Alcohol, right? Or a hydroxyl, whichever way you want to say it, alcohol, hydroxyl. And that's it, tyrosine. So how I kind of remember that one is tyro. It's kind of where the accent falls, like tyrosine has an O. So it's just phenylalanine with another oxygen on it. Tyrosine. That's our second aromatic, R group. And our third one is tryptophan. I hate drawing tryptophan. It looks like the worst, to be honest with you. So just remember tryptophan. Don't let it trip you up. It's to smell good. And those are the 3. So just like we learned valine, leucine, isoleucine for our, what are they all? What group are they under? More specifically, branched chain amino acids, yeah, they are nonpolar, aliphatic, but more importantly, those 3 specifically are our branched chain amino acids. Need to know these 3, phenylalanine, tyrosine, and tryptophan are our, what are they, aromatics. Something, I just came up with this, you can tell me if it works or not. That kind of looks like a P, maybe, if you kind of draw it like that. So tryptophan has a P in it. That P's got a circle. Okay, that was a dud. That was bad. I tried. Can't fault me for trying. Got to know those 3. Questions on those?
I know you said you don't like to draw it, but is it possible that you can draw it anyway? 'Cause I'm trying to get.
Sure. Yeah, this one just didn't help me drawing it, but we can draw it. So basic amino acid structure. So it'll be CH2, C, double bond CH, and There's a nitrogen. Boom, boom, boom. Yeah, and then we just kind of see what I mean, where it's kind of, I'm going to draw it right. So, I mean, if we do it the other way, it can kind of look like a P. Scoot it up, sorry. I'm the worst about that, so please tell me. It's kind of like an upside down P. Not really, sort of. Use your imagination.
Will he ask us about the abbreviations for each of these?
The abbreviations, in what sense?
Like the 3-letter abbreviations, like for each one?
Um,
Only 1-letter abbreviations?
I don't believe so. If anything, I would know methionine as met, because it's your start codon, but that'll be later. But you won't need to know. He's not going to, the answer choices aren't going to be like ALA or, no, he'll have everything spelled out. Cool, moving on. Did that kind of help? It probably hurt me just drawing it, so yeah. So trust me, don't draw it. It's not worth it. All right, all right, we're just gonna start calling on people. What's gonna happen? What's your name? Talon.
Sir.
What is, can you name me one branched chain amino acid without looking at your notes?
Leucine.
Good. Bingo. Who can name the other two besides leucine? First hand. And valine. Good. What's special about glycine? Somebody. Achiral. That's a better toss. Who can name two aromatics? I've already called on you. Have I called on you, Hugh, yet? Oh, no, you're Hugh. No, I haven't called. Have I called on you yet?
Yeah.
Have I called on you yet?
Tyrosine and tryptophan.
Tyrosine, tryptophan. What's the third? Somebody? Someone in the back over there? Phenylalanine. Oh. I'm a quarterback. We'll try that again. She got lucky. Oh, God. I'm not a quarterback. I was barely a receiver. Making it fun. Cool. All right, y'all go walk around for like 5-10 minutes. We'll come back, do the second half. 10-minute break. Yeah, come up and ask me questions if you have them. Okay. For those of you who got up and moved, great. For those of you who just stayed sitting, how do y'all do that? You've been doing that for 12 hours already today. But good for y'all too. Determination. Okay, we are at the polar uncharged R groups. How many of you have bought the book out of curiosity? It does count. How many? Yeah, so I highly recommend it. It just makes life easier. It's probably one of the textbooks you'll use the most.
Does it normally take forever for that book to come?
It does. But awkwardly, they're really good at answering the phone. Yeah. So expect it to take about a week to ship. Yeah, if it takes 2 weeks to ship, that's fine. But if you call them, they're actually really good about answering, and they'll tell you how everything's going. Just for Biochem 2 next try, now you know to kind of buy it before the trimester begins so that when day 1 is there, you've got it. You're not playing like, where's my book? Also, other announcement, I came in the other day and I posted some helpful tips for all the the three big classes, Biochem, DAA, cells and tissues, kind of just a way of how to organize yourself and the questions I answered at the beginning of last session, kind of just typed up, written. On the bottom right, we have the tutoring, the different tutors and their availabilities. A lot of them are during lunch. We have DAA open labs typically on Monday. Our first one's actually going to be tomorrow at 5 o'clock in in the Bones room. Have y'all had lab yet for DAA? Perfect. It's at the end of that hall on the left, kind of, or the middle of that hall on the left, across from the cells and tissues lab. Have y'all gotten the skull packet yet? Yes? When does that due? Next week. All right. Just come do that in the lab, to be honest with you. You can just set aside time and do it with friends or what have you. But that's huge. The earlier you can get that skull down, the way better you'll be off and the less freaking out you're going to have later. Because he's going to ask you whatever he wants about however many things there are. And it's going to help you later on too. So just plan on coming to that tomorrow, even if it's just to do your homework, from 5 to 7. 5 to 7 tomorrow in the DA lab room. I forget, there's a name for it, but I forget it. Cool, all right. Polar uncharged R groups. My ways of remembering these decrease in goodness pretty good right around here, just to let you know. So if they're not as clever and witty, I apologize. I got half of them, so I thought that's pretty good. Polar uncharged R group. We have serine. So if we want to get your basic amino acid group, we've got carbon, carboxyl, amino acids. We've got serine. It should be a 2 and an OH. So all it is alanine plus a hydroxyl. It's high enough? Good. This is serine. And these are polar uncharged. Polar uncharged.
Does it matter if you put NH3 or CH2 in? The whole CH2OH, you put it on the left?
Nope, doesn't matter. Doesn't matter. As long as you kind of keep these together. So you could draw it CH2OH if you wanted to, attach there, and then put the NH3 down here. It doesn't matter.
So it doesn't affect polarity?
No, not at all. So this is a polar uncharged. You need to know the 5 in this category for sure. This is usually the one that, honestly, last try I didn't accent that, and then he picked one, and I was like, sorry guys, I apologize. So no, he'll ask you which of the following is a polar uncharged. So you gotta know those 5. But there's some other important ones in here too. So this one is serine. Serine has this OH group, right? Also called a hydroxyl. For some of us who drink alcohol, we get very relaxed and sleepy. I mean, there's the opposite of y'all who just like go nuts, and good for y'all, but I cannot do that. So how I remember is serine is just a very simple alcohol. So it's got the alcohol on it. It's very calm though. There's not a lot going on around with it. It's just CH2OH. That's how I remember serine. Calm, just kind of tipsy. It's good. Nothing crazy. We're in chiropractic school. We're going to be doctors. Can't be doing that. So that's serine. So serine has an alcohol on it, or has a hydroxyl group. What was the aromatic that has an alcohol on it or a hydroxyl group? Tyrosine, right? Tyrosine, and now we're adding serine. So hydroxyls. We've got tyrosine, serine. There is a third one, and that is threonine. So the next one is threonine. Basic amino acid structure. Gets annoying for me too. Not just y'all. That is just COH. What is that? Where did it go? CH3. H. I don't really care about this, to be honest with you. Threonine. Our basic amino acid structure just here has how many oxygens? 2, right? Just there's 1, 2 here on that carboxyl group, right? Threonine has a third oxygen. There's 3 O's. So that's how I remember that it is another of the hydroxyls. That's the last one. Can I put it? I actually think that one's pretty clever. I usually pat myself on the back for that. So that's just, this is kind of a question within a question. Like you could organize them by, he could organize it by which of the following is like an aromatic, or he could ask you which of the following, similar to a branch chain, which of the following contains a hydroxyl group. And you need to know these 3, tyrosine, serine, threonine, have the hydroxyl group. So tyrosine, tyrosine, serine, sleepy drunk, and threonine, there's 3 O's. There's an extra oxygen on that, so it's hydroxyl. I've got so many blank faces in front of me. Perfect. Not perfect. Does that not make sense to anybody, or is that just so dull now?
What are those 3?
What are the 3? Tyrosine, serine, threonine.
And what's above it?
Hydroxyl. They all contain a hydroxyl group. That's on the bottom of page 18, if you have the book. It's underlined. Those are the only ones. Cool. Any questions on that? Cool. Next. So first, let's kind of go back. We're doing the polar, that's an O, uncharged. And we'll use serine as that example. Doesn't matter how you draw it. This is a polar molecule versus, we'll just say versus, what, like valine? We'll put valine next to it. H, NH3 plus, CH3. We'll just do alanine, whatever, alanine. This one's polar, this one's non-polar. And the reason this one's polar is because of that oxygen. Oxygen is like, an electron just, it's super greedy with its electrons. And so what happens is the electrons that are kind of over here floating around are kind of pulled this way a little bit. So when you're trying to find one, like 6 times out of 10, you'll find it on this side of the molecule as opposed to this side. So there's kind of a slight negative over here and a slight positive over here because of that. If there's more electrons over here, there's more negative charges over here. That's all polar versus nonpolar is. And so like carbon and hydrogen, like they're just pretty plain Jane. They don't really care too much about electrons. They don't hoard them or hide them away for the other atoms. So that's nonpolar.
So it's fair to say that anything has oxygen, I don't think anything has oxygen is polar, more likely to be polar.
So if there is something that has an oxygen, or like we'll see with asparagine or glutamine, kind of like the nitrogen and oxygen in that R group, it's very safe to say that it's polar. Just because we already know what's on that side of the basic amino acid structure, right? Because it's the same on everything. The only thing that's different is on this side. Sorry, I'm breaking your lead. Apologize. Around the alpha carbon, correct. So like here, it's just a carbon and a hydrogen, not that big of a deal. But this one's got an oxygen. Oxygen's a big deal. So polar. That's kind of why I like having some basic idea of what the structure looks like. Because if you can just go back and remember, oh, like there was that oxygen on it, that's probably polar. Or if you can just go back, it's like, oh, valine, it just has like the 3 carbons on it, makes a V. There's no oxygen or nitrogen in there. Probably not polar, probably nonpolar. So just test taking skills. Good question. Next, cysteine. We said we'd get back to it. We're here. Cysteine is just, what is that? Did I do that right? Remember how not tyrosine, what was it? Remember how serine just had an OH there? Right? It's really easy going alcohol. It's like super simple, very calm. All cysteine does is it's just a sulfur. Cysteine, cysteine. It just pretty much has a sulfhydryl instead of the oxygen and the hydrogen on it. And this is our second sulfur-containing amino acid. What was our first one? Methionine. Methionine has that S there. Where is it? Cysteine and methionine are sulfur-containing amino acids. Got to know it. But more importantly, he's going to ask you which one forms a disulfide linkage. And the answer to that one is cysteine. So what the heck is a disulfide linkage? Someone tell me. Just break it down. 2 sulfurs next to each other, right? All that's going to look like is just making some kind of link. There's one here on this page. So you got just like a string of amino acids, right? Proteins are just strings of amino acids. And you can see here that this cysteine and that cysteine, their sulfurs can just bind to each other. They can make covalent bond. And it just helps determine bigger structure of it. We'll get to it. Need to know a test question. What is the amino acid that makes disulfide linkages? Y'all are going to say cysteine. Are you going to say methionine? No, do not. If you do, you're going to get it wrong. I need y'all to be smart.
So where is the disulfide
Make me look good.
in there? Is it between 2 cysteines?
Yeah, it's that squiggly line.
Or that's a covalent bond?
Yeah, those are covalent bonds, yeah. It's just, yeah, the disulfide linkage would be, I guess, that straight line between the 2 S's. Because that, and that makes sense too, right? So Looking at the structure, like the sulfur's the very last thing on the end. So it's pretty accessible to other things, right? And so if there's an S here and just the way it works, there's a sulfur here too, boom. Just kind of like water with its hydrogen bonds, right? We've got that oxygen that's slightly negative, and then hydrogen that's on another atom that's slightly positive. Oh, look, those attract to each other, except those are attractions and those are not bonds, actually.
Same thing, just to make a disulfide bond, and that's important.
Yes, just test question. It helps determine like secondary and tertiary structure of proteins, but just impress your friends. Cool. We are at 13. 7 more. Asparagine, glutamine. These have amido groups on them. Looking over across the way, aspartate and glutamate. So anytime you see like aspar and gluta, those two always travel in packs. It's like Batman and Robin, or whoever else travels in groups of 2. My lead just popped out. Her lead just popped out. I gotta put it back. So asparagine and glutamine, when they have that INE on it, they have that amido group. When it's aspartate and glutamate, they have they've dropped that NH2 on it, or NH2 on it, and they just have this negative charge. So anytime you see the suffix ate, you're thinking carboxylate. You're thinking immediately there's a COO minus on there somewhere. And if there's a COO minus, if we can look over here, we got 1 negative charge up here, 1 positive charge. Those cancel, right? 1 and 1. But now we've got this second negative charge, so these are negative charged R groups. All the other ones before this had there's no positive sign or negative sign on there anywhere. That's why they're just nonpolar or polar. So here, like, it's polar because there's that nitrogen and oxygen over here, but there's no charge. So it's just the electrons are being pulled this way. Whereas this one, there's an actual negative charge on it, making it negative charged R group. So when you're taking a test, and he's asking which of the following is, we'll say aromatic. We'll ask you which of the following or is not an aromatic, what have you. And you see aspartate and glutamate on there. And well, let me just write the question. It'll be easier. Test taking strategies. Nobody should be a bad test taker. I'm going to help you. Which of the following is an aromatic? Okay, we'll have serine, glutamate, aspartate, and tyrosine. My handwriting is super good. Feel free to compliment me on it. So which of the following is an aromatic? Tyrosine, right? Cool. If you have no freaking idea, which is totally fine, that's not. Be prepared for tests. Haha, I'm funny. There it is. Pretty laugh. All the time. I'll take it. That's a U. So if you have no idea, at least remember that glutamate and aspartate go together. Okay? So it's either going to be both of those answers or it's going to be neither of those answers. Okay? So if it's just like a which of the following and it's only one answer, just freaking get rid of those two. Because if it's not one, it can't be the other. And if it is that other, if it is that one, it's got to be the other one. Same thing for glutamine and asparagine. right? Because those are the only two that make up, where is that? Chapter 2. Those are the only two that make up, or that, I mean, those two run together. But those are both in the polar uncharged, and those are the only two that are in the negative charge. So just basic test taking skills. If you see those two together, it's either both of them or it's none of them. And if it's a pick one, just mark them both out because it's got to be both of them. So that question automatically cancels those two out, like that one just did. Does that make sense? Yeah? Cool. So asparagine, glutamine. Those still have that N and the O, no charge. But they're going to be polar, right? Because those are nitrogens and oxygens. Whenever you see nitrogens, oxygens, you're thinking polar. Whenever you see ATE, so aspartate, glutamate, you're thinking negative charge. Because there is that negative charge, carboxylate. Is this too much information now? We only have 3 more. 3 more. So go.
So you don't have to memorize the actual structure?
No. You don't have to, yeah, so none of these is he going to ask you anything about the structure, but just I'm telling you the structure, just that's how I learn best, to be honest with you. And I like having something I can fall back on if I can go back and say, oh, it looked like this, so it's got to be this. That's the way I do it.
For more of what kind of groups they fall into?
So he'll ask you, yeah, so like which of the following is a branched chain amino acid? Which of the following is achiral? Which of the following is a polar uncharged? Which of the following is negative charged?
So he's not going to have like a drawing of our group and say which amino acid this is?
No. This is just like me kind of going through it to show you how to learn it. There's another video that I'll show you like how to like learn it on your hands and cool mnemonic. No, he's not going to put really a picture. Yeah, you need to know the structures of the functional groups. Yes, I apologize. You need to know those. I think he usually does something with like the phosphoanhydride or phospho something. But if you see a P in it, then it's got to be phospho something, right? Not that bad. 3 more. Positive. You've done negative, right? What are our 2 negatives? Aspartate, glutamate, right? That have the suffix ATE. Those are negative. I'm going to teach you. I got a really good friend. Great guy. Great attitude. His name's Hal. Histidine, arginine, lysine. Hal's a happy guy. Good friend. Call him up. Hey, I need something. I need to move. He won't charge you for gas. I drive a truck. It's the worst. So histidine, I don't know these structures. I don't learn these structures. There's nothing I can do. But so it's just histidine, arginine, lysine. The only thing that you have to just be careful about is not calling this leucine, right? But I've drilled that into your head that leucine is what? Branch chain, right? Leucine, branch chain. Okay? So if we're seeing lysine, we know that that's got to be the other L in Hal, who's a good, happy, positive guy. Okay? Histidine is the only H. Okay? So that's got to be the H in Hal for positive. And then arginine, that's kind of like the hardest one to remember for me because there's like an aspartate, an alanine, and a asparagine, what have you. But we already know alanine, right? Alanine's just pretty easy. It's like the step above glycine. What's important about glycine? Achiral, right? It's the only one that's achiral. Just methylate it, and you get alanine. So we know that alanine doesn't have a positive charge, right? It's over here, nonpolar, aliphatic, just a chain, not a big deal. It's not asparagine because if it was asparagine, glutamine would have to go with it, right? Same thing for aspartate, glutamate. So that really is just a process of elimination, arginine. And that's all 20 in less than an hour and a half, which isn't the worst. Sam. So, keep your books open. I'm going to close mine. What are three hydroxyl amino acids? Threonine, right? Yeah, tyrosine, serine, threonine. How are we going to remember that? 3 O's for threonine. Yeah, we got our sleepy drunks. And tyrosine, right? Yeah, so it's a phenylalanine with that OH group on it. Great. What are our 3 aromatics? Yeah, so we've got phenylalanine, right? It's got phenyl in the name. It already tells you it's a circle, pretty much. So that one should be a gimme. Tyrosine, we've already talked about that. That one falls under 2 different categories. And tryptophan, all right? You want to fan good-smelling things to you, right? So tryptophan is an aromatic. Which amino acid makes disulfide linkages? Cysteine, right? Does methionine? No, but what does methionine have that cysteine also has? A sulfur. Good. What are our 3 branch chain amino acids? Valine, right? Valine, leucine, isoleucine. Valine, leucine, isoleucine. Valine, leucine, isoleucine. Y'all should not miss that question. Valine makes a V, right? Leucine, just make it a Y. Isoleucine, just make it a check mark or a Nike swoosh or whatever. Unless you're an Adidas person, then don't make it a Nike swoosh. But no one's an Adidas person, if we're being honest. You're welcome. What are our 2 negatively charged amino acids? Aspartate, glutamate, right? If we see an asper and we see a gluta, those have to go together, right? So making sure, so even if he puts a test question, so which one's negatively charged? Aspartate, glutamate, or asparagine, glutamine, right? You need to be able to differentiate even between those 4. So when you see the suffix ate, we're thinking negative. We're thinking negative. It's lost that hydrogen, and that hydrogen took that electron with it, which is why it's negative. Let's see. Serine, what big category does that fall under? Polar, yeah, right, yeah, it's an alcohol, but that's, we're going like big category, so like one of like the bold ones on the thing. So that's a polar, right? Polar, is it charged or uncharged? Uncharged, right? Our charged are just those 5 that were on the right-hand side of the page. So hal and aspartate glutamate. Everything else, uncharged. We only have 5 charged ones, hal and aspartate glutamate. So 75% chance guessing uncharged, if you're an odds person. What else is under that category of polar uncharged? I forgot myself. We've got, so we said serine, threonine, cysteine, asparagine, glutamine, right? Good. What are our 3 positive ones? Hal, and what is that? What are the ones that actually spells? Histidine, arginine, lysine. That was the one that took me the most time to figure out, just because they were like not as straightforward, and there's a bunch of A's already. So just spend a little bit extra time on that, especially since it was last. That's all you can really ask y'all, guys. That's like pretty much all I can ask you, is just can you group something into the right category, or can you take something and know that it doesn't belong to that category? That's all I can ask. But finishing up real quick, try to end here. How many pages do I have left? More than I thought. Okay. This is just talking about a disulfide bond. It's with cysteine. Pretty much it just takes the hydrogens off and makes water. Not a big deal. Need to know this word here. Zwitterion or Zwitterion, or I don't know how to say it. Say it however you want. You need to know the definition of it. And it's something that can act as either an acid or a base. So if you put up your notes, sorry. Zwitterion or Zwitterion or whatever. I've been told I make it like a hookum in like everything I do, so if you see that, go horns. So it can act as either an acid or a base. Acids donate protons, bases accept them. Then also know amphoteric. It's underlined and bolded, so if he's going to underline and bold something, he's probably going to want you to know it, yeah? Probably. Am I giving you a headache? I'm sorry if I am. Cool. Just know those definitions. Amino acids are often characterized by the pH at which the net charge is 0. You need to know this word too, isoelectric. So that's just when the net charge is 0. That would be like any of our nonpolar or polar ones, right? Because they only have that one negative and that one positive on the basic amino acid structure. So those just cancel each other out, net charge of 0. Our positively charged ones have a positive charge. So those would not be isoelectric. Titration of glycine, don't worry about it. Have him go over this with y'all, if you would. I honestly don't do a very good job of explaining it, but is it that one or yeah? So there's gonna be some kind of test question of at a pH of like 10, is this amino acid protonated or non-protonated? And I always forget, I always just mix them up. I'll try to look that up. One y'all can email me or just I'll write a note to look up. You're gonna have to know it for the test. So if he covers this tomorrow, or if he asks you if there's any questions, be like, hey, can you explain this graph for us, please? And how pH determines all that stuff. That'd be good for y'all. TQ here, amino acids are polymerized. Pretty much you can just say formed or made, created, whatever, by condensation to form peptide bonds. I remember missing this in undergrad. It was the worst. And he might ask you this too. So pretty much the different bonds that connect different amino acids and chains are peptide bonds. So scrolling over here, we can see all of these highlighted highlights. These are our peptide bonds. So we're taking what amino acid? We're going to test y'all. This is kind of fun. What amino acid is this? Serine, right? Pretty simple. It's got an OH, but it's pretty simple. Tyrosine, would there be a phenyl group right there? What is this one? Glycine, right? It's just an H. It's just an H. What about this one? I just gave it away. Tyrosine, right? Tyrosine. What is this one? Alanine. Good. And what about this one? What does it make at the top? Yeah. So that makes it a leucine. Oh, y'all are so smart. And pretty much all it does is it takes the carboxylate on one, or the carboxyl group on one, and the amino group on the other, and it takes some hydrogens out. And actually, it takes an oxygen and a hydrogen out, 2 hydrogens out, making a peptide bond. Know that it's condensation. Peptide bonds make proteins. It's actually really, really important. So our body is basically made up of all the proteins in our body are made up of some variation of all these things. And our proteins are pretty important. We'll get to that a little bit later, but they help determine our like the structure of our cells, and they carry out all of our enzymes are actually proteins in nature. So everything that breaks down fats and proteins in our body and things that signal different cells, like all these things have different proteins in them, which are made up of amino acids. So it's kind of why we're learning our amino acids, is they play a really big role in our body. And here's just a couple of things that he says they do. We can permanently change amino acid structures by putting an OH on it, by putting a C. Actually, y'all, here quiz, functional groups. Draw the functional group next to it. Ready to go. Or think about it. I'll give you all like a little bit of time just to do that. So pretty much just take off the like ation, and that's the functional group. And just draw it real quick. Oh, acetyl. What are the last two? You're just adding carbohydrates are, oh shoot. I think those are just carbons and hydrogens, that's it. And then lipids, we haven't learned those two yet. Cool, all right, so hydroxylation, we're adding a what? OH, right? What are our three OH amino acids? Threonine, tyrosine, serine, right? If anything, remember the sleepy drunk. Come on, seriously. Anyway, carboxylation, what are we adding? So we'll do this, OH. This one we're adding COO minus or COOH, what have you. Methylation, what's a methyl group look like? CH3. Acetylation? I honestly don't know what it is, to be honest with you. Is it in the back? Is it in our book? Did we learn that one? Did we learn what an acetyl group is? Acetyl. C. So it'd be like C double bond O, C, H3, something like that. Sorry. C double bond O, CH3. If you don't know that one, make sure you look over that one later, because you might ask that on the test. It's one of those kind of hard ones. Phosphorylation, what are we doing there? Phosphate with all the different O's, right? All the O's are different. This one's got a negative, that one's double bond, that one's got an H on it, that one's connected. Pretty simple. And then you can just add carbs to it, or you can add fats to it. Good. That was a good quiz. I like that. That's just all the different oxygens. So that one's got a negative, double bond, an H, and that one's like connected to like the rest of the structure. Two more pages. Get you out of here a little early. Wonderful. And this is just kind of showing you the addition of it by carbohydrates and lipids. If y'all want to learn some stuff, read that. Done. Questions?
I have a question about the
Yeah.
quizzes. I know they're online, but like,
He's just going to be, so his quizzes, don't freak out about them. They're not that bad. You should get 2 chances to do them, unless he's changed it. So like if you do like really not well the first time, don't worry about it.
Do you know how much time is given on it?
It should be at least 10 minutes.
For 10 questions?
At least 10 minutes. I think it's like 20 though. he should tell you all that in class tomorrow. But they're not that bad. Like I said, you can take them twice. Try to have your notes out with you. Everything's going to come pretty straight from the notes. Y'all are ahead of the game. I think y'all are ahead of him at this point right now. So that'll probably be good. When I took this class, I was behind him the whole time, trying to catch up, and it was a nightmare. So take advantage of this now. All the quizzes are just like worth 1% individually. I'll just say I have just a couple more minutes with y'all, please. All the quizzes are worth 1% individually, so it's just a really easy way to get 100 and just add 1 point to your grade. These, just try your best to get 100, and it should only help you. You could. I might not have the answer though. That class has been changed a lot. They should. Oh, like, is it from the readings? What's y'all's quiz over? Do y'all know? Who's teaching that class? Russell. Because he took that. I took that like the second try that he'd ever did it, and he's changed it since I've taken it. So I'm honestly not quite sure. So you can ask to try 2 across the hall, and they might have a better answer for you. If he gave you a reading, make sure you read it. It's not going to be an easy guess if you don't read it. Any other questions, comments, concerns, compliments? Thank y'all.